Hi, welcome to my channel. Today we are going to learn about rocket, how does the rocket work and what is process. How do we launch things into space? NASA says that we launch things into space by putting them on rockets with enough fuel. That fuel is called propellant to push them about most of the Earth's atmosphere. Once a rocket reaches the right distance from the Earth, it releases the satellite or spacecraft. Let me explain you in a simple way. Actually, NASA will launch what? Satellites, spacecraft, rockets. So, actually, that satellites, spacecraft will be carried by rockets. Okay, here is the main thing which you observe here. We launch things into space. We are launching the things into space by putting them onto the rockets, and rocket will carry. To make it carry, the rocket needed some fuel. That fuel is called propellant. So by that propellant, the rocket will move to boost them above most of the Earth atmosphere. So what will happen once the rocket reaches certain distance or right distance from the Earth, it releases the spacecraft or satellite. So simple, understand? Next. Okay, NASA says that we launch satellites and spacecraft into space. Okay, by putting them on rockets, rocket will carry tons of propellants. Why tons of propellant? I will explain here. The propellant gives the rocket enough energy to boost away from the surface. Okay, because of the pull of the Earth gravity, largest, heaviest spacecraft needed biggest rocket and most of the propellant. So actually, what will be happen due to Earth gravity? What will be happen? Each and everything what will you throw up will come down. Okay, so like that only, Earth gravitation is there. So to overcome that gravitation force, we needed most of the propellant to make our rocket fly higher and higher. So now next, how does a rocket lift off? So the answer is, more than 300 years ago, a scientist named Isaac Newton laid out three basic laws of motion. Okay, that describe the way things move. One of the laws says that here the rocket, for rocket, which law is applied? Newton's which law is applied means here the Newton third law is applied for the rocket. So here what will be I am saying? So what's one of the laws says that for every action, Newton third law states that for every action there is an equal and opposite reaction. So this is the most important idea behind how the rocket works. Do you understand? Okay, next. If you see picture of rocket or videos of a launching and rocket, you will see exhaust streaming or the bottom of the rocket. Okay, exhaust is what will be happening? Streaming bottom of the rocket. That exhaust is nothing but flames are coming out from the bottom of the rocket. So dirt flames are nothing but hot gases and smoke that come from the burning the rocket's propellant. By burning the rocket propellants, what will be happen means hot gases are exhausting by exhausted in the form of flames. Okay, the exhaust pushed out of the rocket engine down toward the ground. Exhaust is pushing the rocket towards the ground. The flames are pushing the rocket towards the ground. That's the action force. So for every action there is equal and opposite reaction by Newton's third law. So here in response for that action, here is the response. The rocket begins moving in opposite direction, lifting off the ground. That is the reaction force. The exhaust pushed it out of the rocket engine downwards, down toward the ground. That's the action force. In response, the rocket begins moving in opposite direction, lifting off the ground. That's the reaction force. That's it. Next, once a rocket launches, will it keep moving? Okay. Now the answer is it's not that simple. Earth gravity is still pulling down the rocket. Earth gravity will be present. It will be pulling down the rocket. When a rocket burns propellant and push it out exhaust, that create an upward force. Remember, it's a very important. That upward force is called thrust. Okay, it is not simple. Earth's gravity still pulling the rocket towards the downwards towards the ground. When a rocket burns propellant, what will be happen? It pushes out the exhaust. That's create an upward force. Here the upward force is created in the rocket. That is called thrust. To launch the rocket, we need enough propellants so that the thrust pushing the rocket up is greater than the force of gravity pulling the rocket down. Do you understand? So here what is to launch rocket we need more propellants as said. Heaviest rocket needed heaviest propellant to move in forward direction. Forward direction is moving means thrust is moving in forward direction. So that forward to move in pushing the rocket up. So that energy or that force must be greater than the force of gravity pulling the rocket down. No, not energy, force I am saying, force. Next, a rocket needs to speed up to at least 17,800 miles per hour and fly over most of the Earth atmosphere in a curved path around the Earth. This ensures that it won't be pulled back down to the Earth. But what happens next is different, depending on where you want to go. It's it. Next, how to orbit Earth. Let's say you want to launch a satellite that orbits the Earth. The rocket will launch, and when it gets to a specific distance from the Earth, it will release the satellite. So the time will be taken. After what will be happen, the rocket will launch, and when it's get into this specific distance from the Earth, it will release satellite or spacecraft or anything. The satellite stays in orbit. Okay, the satellite is staying in orbit. How it is staying in orbit means the satellite stayed in orbit because it still has momentum, energy. It picked it up from the rocket. Okay, pulling it in one direction, Earth gravity pulls it in another direction. This balance between gravity and momentum keep the satellite orbiting around the Earth. So by first one is what? Momentum energy. Next one is what? Gravitation. The balance is this balance between gravity and momentum keep the satellite orbiting around the Earth. So that's why the satellites moves around the Earth. Is okay? By the use of satellite, we are seeing television and weather forecasting, and so many useful things are done by that. So satellite that orbit close to Earth feel a stronger tug of Earth gravity. To stay in orbit, they must travel faster than a satellite orbiting further away. I think so. You understand well. Thank you.